Welcome. In this video, I would like to talk about the scientific method. So first off, what is the scientific method? The scientific method is the process used by scientists, or really anyone else, to answer questions about the world around us. Why is it important? Well, I think it's important for everyone to be familiar with the scientific method, because in our modern world, science really is woven into our lives, and the scientific method is actually, it's the core of science itself. It's the basis for scientific thinking. So I'll introduce you to these steps first, and I'll go into further detail about each one. So first there's a question, then the research, then the hypothesis, the experiment, the results, finally there's the conclusion. So now let's start with the question. So the question is really just any question, but it needs to fit one requirement, and that is that it must be testable. Testable. So what does testable mean in this context? So testable means that you can answer this question using data, numbers, or observations. So for example, and I'll use this question for the rest of the lecture. For example, the question, what is the most viscous liquid? That is a testable question. Viscosity, meaning pretty much the same thing as thickness in the case of liquids. That's testable because viscosity is something you can measure, you can quantify. The question, what is the most beautiful flower, on the other hand, is not really testable because it's a matter of opinion, and thus it's really beyond the scope of science. So it needs to be a testable question. That's very important. So once you have a testable question, you can move on to the next step. The next step is research. So first of all, what kind of research would you want to do? Well, you just want to research about the topic. The reason for this is that you'll learn some background information about what you're investigating. That's important in order to do a good scientific study. For example, in this case, you'd research about what viscosity is, how liquids behave, what affects liquid behavior, things like that. So another reason you would research is that so you can see if this idea has already been investigated, and then you would decide if you still want to investigate it or not, and also learn about the works of people that have done similar things before, or maybe some current research. So research is important. It just informs you about your topic. So once you have researched, you can form a hypothesis. A hypothesis is just an educated guess. So it's called an educated guess because you've already done your research, you know about this topic, and now you can just make a prediction as to what the answer to this question is. So if you're just from some of the liquids you're testing in this viscosity example, you could hypothesize or predict based on your research that the most viscous liquid is molasses out of the ones you're testing. So you just make that hypothesis. And hypotheses don't necessarily need to be proven correct, but it just gives you something to work with and something to think about before you begin your experiment. So then the next step is to actually go out there and experiment. So ultimately the goal of the experiment is to come up with some data, some results, some observations, so you can answer your question. Experiments should be accurate, and ultimately they should fulfill the goal of answering the question. So in this viscosity example, one way you may have encountered in your research to measure viscosity is to pour the liquids through a funnel and then time how long it takes for liquid to go through. That would be one way, for example. So you design that experiment, so that would indicate what the viscosity is relative to the other liquids for each of those. So there are some important things to keep in mind when doing an experiment to make sure the results will come out accurate, and then you can use them to answer a question. Repetition is good. It's good to repeat your tests, your experiment, and if you get consistent results, consistent data, that's a good sign because it's reaffirming what you discovered maybe in the first experiment. So repetition is a good thing. Usually at least 3 times for good science. The other thing is variables. So there are 2 kinds of variables. There's independent and there's also dependent. Okay. So, independent variable. That's a variable that you're testing. That's the one that you're measuring. So, and the reason why they're called variables is because there's situations or numbers or things that can change in your experiment. So this independent one, this is the one you're measuring, but it can change. It might be different for each liquid, for example. So that's the independent variable is just the one you're measuring, and usually you only want to have one at a time. That will be the one you'll use the results you get out of measuring this variable to answer your question. So in this case, the time it takes for the liquid to go through the funnel in seconds, for example. The dependent variables are just the other variables that usually you're able to control, but they can impact your independent variable, and they often do. For example, the temperature of the liquid, the size of the funnel's hole, the amount of liquid you pour in the funnel, the type of liquid. So there are all these different other variables that can affect the one you're measuring. So it's important to control them and only change one at a time. So in this experiment, you'd only want to change the type of liquid because you're actually looking to see if there's a difference in the type of liquid. You'd want to keep all the other ones the same because then if you get a different result for each liquid, you know that it's actually the type of liquid that's causing that difference and not some other variable in your experiment, say the size of the hole in the funnel. That would confuse your results if that got mixed in there. So you do want to make sure to think of all the variables you can and control them, except the one you do want to change. So then the results are just basically data or observations that from taking your measurements of this independent variable in your experiment. They're usually just numbers or observations. They're not very useful in just a regular form. They're kind of hard to understand or hard to present. So a lot of people, and it is a good idea, create charts and graphs to help visualize their results. That's very helpful. So once you have your data, your results, you'll draw your conclusion. That's just when you basically connect these dots. You go back to your question using your results. In this case, the time in seconds that it took for each liquid to go through the funnel, and you'll answer this question. So you'll say such and such liquid is the most viscous because it took the longest time to get through the funnel. So you'll just draw a conclusion. You'll answer this question. You'll also go back to your hypothesis. You'll state whether it was proven correct or incorrect. It's okay if it was incorrect. An incorrect hypothesis is just as valid as a correct hypothesis as long as the experiment was done accurately. So you just connect the dots in your conclusion using your data, and you're done with that last step. So just to give you a recap, you start by asking a question, you do some research about your topic, you form an educated hypothesis, you do an accurate experiment, you'll get your results, you probably want to put them in a visual form, and you draw your conclusion, go back to the rest of your experiment. Hope that was helpful. Thank you for watching.